for the great start into the event. Can you hear me all right? Can you see my slides?
Yes, we can.
Excellent. Yeah, it's my pleasure to walk you through the key results from the SHAPE project, to introduce our new sustainable development pathways, and also to explain why reflecting these different perspectives is so important. I should highlight this is really based on the work of the full SHAPE consortium. So there's 4 modeling teams behind that. There's the colleagues at IDOS from environmental governance, and also our great SHAPE stakeholder process team that many of you have already been in touch with. So let's start by taking a step back. As we've already heard, there's this twin agenda of the Paris Agreement and the Sustainable Development Goals strongly intertwined, with SDG 13 highlighting climate action, and vice versa, the Paris Agreement highlighting the context of sustainable development and poverty eradication for climate action. And around this, there's a really rich and a growing body of research on sustainable development indicators, targets, and trends, on synergies and trade-offs, often between climate and other SDGs, but really also between every other pair of SDGs. A discussion about the role and the limitations of models in general, and IAMs in particular, integrated assessment models, to inform the sustainable development agenda, but also broader, more interdisciplinary and transdisciplinary approaches. But when we started SHAPE, we also saw 2 key research gaps, which is that there was a lack of really encompassing universal narratives for sustainable development pathways that can be used across different research domains. And related to that, there was a lack of more holistic sustainable development pathways that put away the silo thinking, looking at individual goals, but really looked at the full agenda. And that is essentially what we tried to tackle with SHAPE. So just to give you a notion of what we mean by sustainable development pathways, this is essentially achieving high levels of human well-being within planetary boundaries. And just one way of putting this was in the recent IPCC report, here showing Human Development Index, HDI, versus greenhouse gas emissions per capita. And the sustainable development space is at the bottom right of that figure, so high levels of HDI versus low emissions. And essentially no country is in that space today. High-income countries need to move to lower emissions, and low-income countries need to move to higher levels of human development. And that already makes it very clear that sustainable development is region-specific. And as was already mentioned multiple times, even within the same country, the same region, there are different perspectives how to pursue sustainable development, and this needs to be reflected in multiple pathways. It's also clear that 2030 is just a milestone, so we need to cover what we call the SDG plus space, so also going to 2030, 2050 and beyond, that we need to combine these multiple interlinked transformations of human society and nature systems, and that it's really important to look at synergies and to avoid or mitigate trade-offs. So let me give you a very brief run through how we set out to build those sustainable development pathway scenarios within SHAPE. We started by identifying relevant dimensions of sustainable development, and here it's really important that we had the social sciences on board as well. Then within each of those dimensions, we created alternative strategies for that dimension, how to pursue sustainable development, and then we aligned those dimensions to overarching scenario narratives. So these first 3 steps happen at the purely qualitative or narrative level, and the wheel figures that you can see at the bottom is kind of a visual representation of that, of the outcome of that process. Then this went over to the modeling side. We translated the narratives into a modeling protocol based on that, quantified the scenarios using integrated assessment models and industrial ecology models. And then our colleagues from the governance side took over for pathway appraisal. And what was really important for us is that over the entire process, we had a continued stakeholder dialogue and co-design process. And this is why we hope that these scenarios actually really reflect these different perspectives, regional perspectives, societal, economic perspectives on how to best pursue sustainable development. Now let's have a look at the 3 narratives that we decided to focus on and that we later quantified. I would ask you to keep the abbreviations and the colors in mind, because these will pop up later on during my and other presentations. The first one we called economy-driven innovation, or EI for short, where technology, innovation, and efficiency are really the key drivers of transformation. The economic outlook is continued economic growth, and economic instruments such as pricing are the most important policy instrument. In many ways, quite the opposite is the resilient communities narrative, or short RC, where solidarity, well-being, sharing are key drivers of the transformation. The economic outlook is towards post-growth, at least in high-income countries, and lifestyle change, low consumption patterns are driving the transformation. Last but not least, we have the managing the global commons, or MC narrative, where strong international national institutions are driving the transformation. Regulatory policies are a key policy instrument, and the economic outlook is more moderate. Based on these three narratives, we started the quantification. As I already mentioned, we first built a modeling protocol, which you can think of as a structured qualitative translation of those narratives into settings that can be used by models. And then based on that, all models within Shape interpreted and quantified those scenarios, but we deliberately left room for individual models to make their own choices how to best represent those pathways. And we have 4 models in total. 2 of them, Remind Magpie, that we develop here at PIC, and Image from the colleagues at Utrecht University, are what you might call full system IAMs. And then we had 2 models for sectoral deep dives, Message, which is also an IAM, but here we used it mainly for the building sector, and ODEM-REC, which is a material flow analysis model. And then all of these models calculated really a large number of sustainable development indicators that we then compared on the one hand between different pathways, but also within the same pathway between models. And for my presentation, I will broadly group them into socioeconomic, energy, materials, land and food, and climate, and other overarching indicators. I should also say that some of these indicators are mainly narrative or assumption driven. So think of those as a translation of the narratives, and others are true output indicators from the models. And I'll try to make that clear as I go along. Now, before I jump into looking at indicators, let me just highlight some common features and differences of the Shape SDP scenarios. So all 3 SDPs, the economy-driven innovation, the managing the global commons, and the resilient communities, aim to meet the SDGs, or at least make as much progress as still possible until 2030. We assume that population and underlying education and demographics are the same for all 3 scenarios. And of course, all 3 SDPs require functioning and stable governance kind of as a prerequisite for the transformation. However, importantly, the individual strategies and policy options used in the different sustainable development pathways differ quite substantially, and this is really a reflection of the different narratives. Let me just highlight briefly the climate side of things. So all SDPs meet the 1.5 degree target with just a small overshoot and then going to below 1.5 degrees again. So in that sense, they are similar. And we also contrast them with 2 further scenarios. One is a reference scenario where we follow current trends. And one is a scenario where we only implement climate policy, but no further SDG-oriented policies. And in the figure, you can see what this means for global CO2 emissions. And this is really just to repeat what is common knowledge, and what Johan also showed is that in order to meet the 1.5 degree target, you need to essentially cut CO2 emissions to 0 by the middle of the century. And that's true for all 3 SDP scenarios and also the climate-only scenario. So now let's jump into the individual indicators, and I'll start with the domain of economics. So here I'm showing global GDP per capita, and this is actually something that we harmonized across all models. So all models use that translation of the narratives into economic development numbers in exactly the same way. And the 3 narratives, I have them on the left of the slide. The EI narrative has continued high growth in all regions. The RC has a post-growth outlook in the global north and the continued growth in the global south. And the MC has a moderate growth in the global north and high growth in the global south. And in the figure, you can see how that translates into global GDP per capita. And at the end of the century, the numbers range from around about $45,000 per capita in the RC to around 100,000 in the EI narrative. So there's quite a big space that is covered between them. Of course, the global numbers are only part of the story. Really important is the regional convergence. And there's actually strong convergence within between regions in all of those sustainable development narratives, but the convergence level is quite different. So for example, you can see in the blue, in the economy-driven innovation scenario, essentially high-income countries here represented by Europe with the dashed lines continue to grow, and the low-income countries here represented by Africa in the solid line catch up to that level, whereas in the resilient community scenario, there's essentially almost no further income growth, a post-growth outlook for high-income countries, and low-income countries catch up to that lower level then. This, of course, has important implications for poverty eradication. Before I talk about the results, let me just mention that we also have scenarios for inequality within countries. We recognize that all sustainable development pathways need to reduce inequality rapidly, much faster than any reference scenario. And within the SDPs, the resilient community scenario reduces it its slowest. And you will hear much more about this in the afternoon by Ji-Hoon Min. What I'm showing on the figure is actually an outcome indicator. That's the population above a poverty line of $3.20. So that's a bit higher than the international poverty line, as this is often criticized for being too low. And what this takes up is, of course, both the trend in GDP per capita and inequality, but also the effects of climate policy on energy and food prices and a potential redistribution of carbon pricing revenues. And what we see is that in the reference scenario shown here by the black line, poverty is reduced only slowly. If you were to do just climate policy, that would even lead to a slight increase of poverty over the reference scenario because of energy and food price increases. However, all three sustainable development scenarios reduce poverty rapidly, and the RC scenario does so fastest. Now let's move over to the energy side of things. And the first indicator that I'm showing here is final energy per capita. This is again more a reflection of the narratives, but translated by the models. On the left-hand side, you can see again what we have in the narratives. In the economy-driven innovation scenario, high demand for energy services, but also high efficiency. In the resilient community scenario, much lower demand for energy services through behavioral change, but also more moderate efficiency increases. And the MC scenario somewhere in between on energy services, but also has high efficiency. And on the figure, you can see how we quantified this using the two full system models, IMAGE and MAGPIE. I'm showing both the results from the two individual models, and these shaded funnels is the range of the model results. And we were quite happy to see that actually we got relatively similar answers for these trends in final energy per capita. In a reference scenario, energy use continues to increase, and all three sustainable development pathways break with that trend. The EI scenario stabilizes at levels a bit below today, and the resilient community scenario goes much deeper, driven by the low demand for energy services. Importantly, we checked this against energy requirements for decent living, especially in the global south. I just put this in a very sort of sketchy way with this 20 gigajoules per capita and year line. You will hear much more about this decent living energy in the afternoon from Jarmo Kikstra. Of course, there are many drivers of energy use, and let me just pick out two of them. One is floor space per capita, so how much building space we use that determines the need for heating and cooling, and also for building those in the first place. And this is reflected as floor space per capita in these different scenarios. I have now many model comparison plots that have the same style as this one, so let me just explain that briefly. On the x-axis, you have 2020, 2030, and 2050, which are the key time steps that we looked at. And then the different colored ranges are the ranges of the different model results, and overplotted are always the individual models. And this gives you the ability to compare both between different scenarios and between different models. What we found for this floor space trend is that from 2020 to 2030, so in the current decade, floor space per capita still increases in the global average. This is mainly driven by increases in the global south. But then you actually start seeing a larger difference between the different narratives, where the resilient community scenario stabilizes floor space at roughly those levels, and the other two, the EI and the MC, have a trend of continued growth in floor space per capita. The second one I want to look at is the production of iron and steel as one prototype of energy-intensive materials. So again, what we find is that in reference scenarios, the production increases all the way to the middle of the century and beyond, whereas all sustainable development pathways can roughly stop any further increase, and especially the case of the resilient communities and managing the global commons scenario, they can stabilize the need for iron and steel at levels below today. But as I will explain more in detail afterwards, the strategies behind that are quite different. This is related to how high material demand is and how high the recycling rates are. And you will hear much more about that specifically also in the afternoon. Now let's move over to the energy supply side. It's clear that all climate mitigation scenarios that meet the 1.5-degree target need a really high rate of electrification by the middle of the century. And that's also true for the SDPs. But they even enhance electrification over the climate-only scenario, reaching electrification rates of up to 60-ish% by the middle of the century. And the drivers behind that are again quite different. In the MC scenario, it's mostly stringent regulation. In the EI is technological development. The RC scenario in yellow has slightly lower electrification rates because overall demand is much lower. So the push to electrify is just not as strong. And we also looked at health effects from energy use, particularly from air pollution, because this is quite an important interlinkage between energy use on the one hand, climate policy, and human well-being. Actually, there's kind of a bidirectional effect here. On the one hand, there's a clear synergy that climate policies reduce ambient air pollution, for example, through switching of coal power plants. On the other hand, there's also a potential trade-off, which is what I'm showing in the figure, that climate policies have the risk of making modern energy carriers more expensive, especially in developing countries, and therefore slow down the uptake of modern energy carriers, which means that polluting fuels like traditional biomass burning within homes stick around for a bit longer. And we quantified this, for example, with an indicator for child mortality from this indoor air pollution. And here you can see that the reference scenario reduces this only slowly. Climate policy even leads to yet slower reduction, but all three sustainable development pathways accelerate the uptake of modern cooking fuels and therefore avoid this issue with indoor air pollution for the future. Now let's switch gears a little bit and jump over to the food and land use side. Again, in the narratives, we have a rich representation of the future food and land use system, which we then translated using the models. And this ranges from relatively modest changes in the EI, so adequate calorie intake and modest reduction of food waste, and just a slight uptake in animal-free meat and milk alternatives, over to a really rapid, ambitious transition to healthy calorie intake and healthy nutrition, like the Eat Lancet diet in the resilient community scenario. And in the figure, you can again see this represented for Africa and Europe as two prototypes of Global South and Global North, where again, we see a convergence between regions, but the convergence point is quite similar, quite different at relatively high calories per capita and day level of over 3,000 in the EI scenario and much lower, close to healthy calorie intake in the resilient community scenario. Food demand is, of course, the single most important driver for human land use, and therefore these trends then have very different consequences in land use. And I will just pick a few examples here. The first one I want to look at is the change in forest area, so afforestation, deforestation, and I'm just showing the change from 2020. It's clear that all Paris-compatible scenarios need to stop deforestation and increase forest area, which is also true for the SDPs. And what we found is that the forest area increase is actually broadly comparable to standard 1.5 degree scenarios. However, the strategies are quite different within the SDPs. So the EI really pushes for higher land productivity and targeted afforestation with kind of plantation species, whereas the resilient community scenario focuses on freeing up land through dietary change and then protecting that land for natural regrowth. And this then has, of course, consequences for biodiversity too. So all SDPs stop and reverse biodiversity loss. However, improvements are relatively modest in the EI scenario and much stronger in the resilient communities, which is, again, at least in part, due to this plantation forest versus natural regrowth question. We also looked at the trade-off or potential trade-off between climate policies and food security, which can be caused by land competition through land-based mitigation policies. So what we see is that in the climate policy only scenario, in the red one, you actually increase food prices quite substantially. However, all of the sustainable development pathways can avoid that food price increase through the additional sustainable development interventions. And again, the underlying mechanisms are quite different. Improved technologies in the food system in the EI scenario, for example, and dietary change in the RC scenario. And especially the RC scenario with its strong dietary change leads to a substantial reduction of food prices in the long run. So there's even a synergy with food security. So this was a bit of a tour de force through different indicators. Let me now come back to the very beginning and come back to the climate. It's clear that meeting the 1.5 degree target requires substantial carbon prices already by 2030 and a further increase until 2050. And you can see the required prices for a climate only scenario in red. So by 2050, they range from a few $100s per ton over to over $600 per ton between the different models that we used. And the sustainable development pathways reduce the required carbon prices again through different strategies, through demand side shifts in the RC scenario, through technology and innovation in the EI, and a mix of both in the MC scenario. And reducing the carbon prices is especially important in terms of global equity. So reducing, at least in the near term, carbon prices in the global south because of potentially adverse side effects. And picking up on that theme of global equity, we also have the varying degrees of international collaboration as a dimension in the narratives. And we reflected this, at least in the Remind Magpie model, through a calculation of international climate finance transfers. So the underlying assumption is that in all of the SDP scenarios, there's some redistribution of carbon pricing revenues into an international climate finance scheme. However, how exactly that scheme works is differentiated between the scenarios. And what we find is that the managing the global commons scenario with its high emphasis on global collaboration would see the largest international transfers. Here you can see again, Africa receiving the largest funds. So that's the bar going upwards in the MC scenario, and Europe with the bar going downward in the MC scenario, they would pay the most into this international climate finance transfer scheme. So with this, I will wrap things up. The SHAPE SDPs explore pathways towards the climate targets and the SDGs, and the goal is really to break with the current trends of being not on track for either. The underlying narratives are based on a co-design process, and we hope that we manage to really represent those different perspectives on how to pursue sustainable development. What we found is that the SHAPE SDPs really facilitate to reach ambitious climate targets, and they avoid many of the known trade-offs of climate-only pathways. The underlying strategies are very different in the RC through post-growth and low demand, in the EI through fast technological development, and in the MC through targeted regulation. And it's this multi-scenario and also multi-model approach that allows us to look at what are robust strategies for sustainable development, what are synergies and trade-offs, but also what are key bottlenecks. Because it's clear that different pathways have pathway-specific strengths that I tried to highlight during the presentation, but also some pathway-specific challenges. And I already mentioned that, for example, DEI only leads to modest improvements of biodiversity. The MC with the highest international climate finance might pose a challenge for international policy making, and the RC with its lowest per capita energy demand levels might have an issue with residual energy poverty. Many of these questions are also looked at again in the governance dimension in terms of the pathway appraisal that you will see in the afternoon. So I will stop here and let me just close off by saying that our goal with SHAPE is really to inform the SDG and Paris implementation, not just in this decade, but also for post-2030. So I really hope the results are useful in that sense. And now I look forward to the discussion with you.